Hey guys, I believe that you can hear me now. I didn't watch my last stream, so I don't know if the audio is okay or not. Probably it is. Well, it's almost 10 p.m. I should have started streaming earlier, but honestly, I didn't feel like it. Um, um, I did. I went to. Yeah, basically, I didn't feel like it. To summarize it, um, tomorrow I will go to a church. Can you believe that? Me going to a church? I'll put this music to resemble my new encounter fate. My new discovered fate. I actually don't believe that much in God, to be honest with you guys. And to be honest as well, I'm just doing it for socializing more a little more, since all social uh, my social environment is my work, and I don't want my work to be my life, you know. My life is much more than that. Should, should be more, should be much more than that. Um, and that's actually what my job wants. I mean, I have the feeling that the job wants the job to be my life. And I make it win. Because before streaming I was playing with my friends. Wait, I will. Yeah, that's better. So before streaming, I was playing with my friends at work. And it's Saturday, right? I don't know if I should be doing that. I have many stuff to do. Like streaming, right? I should be streaming so I can quit that job. But I don't know. Honestly, I feel really, really alone, man. um, I don't know. I don't know. I feel really alone, and nobody. I have nobody to tell my problems. So yeah, I don't know. I want to believe in God, so I have someone to talk with. Yeah. I think that that's one of the reasons why I want to. Yeah. And that's one of the reasons why I play with my coworkers. Not because they are my friends, just because I feel lonely. And I want someone to have fun with. To talk with. Yeah. Even though I want to quit a job. They are good people. I'm not get me wrong. They are they are good people, funny to hang with, and they are good people in general. But I have. I also. Bro. I also have to do stuff so I can quit the job, man. And it's already 10 p.m. Last week, I also did play with them, and the week before that, I think that I also did play with them, man. So I don't know. So yeah, I also want to decide to record more videos. song, but because of how the stuff work, you know, with your song, how the copyright works with your song, how strict it is. I love this one, man. Looks like we've made it. Look how far we come, my baby. Yeah. So yeah, that's been me. And a couple of hours ago, I was playing with my coworkers, and we already stopped. So yeah, that was my Saturday, man. So tomorrow I will go to the church like at 9 a.m. And let's see. Let's see. I hope that I find people not necessarily my age, because it's hard, right, to find them in a church. I don't think so, man. But I mean, I don't know. I just don't want to feel so lonely. And I don't want to be so dependent on the bill of my job, since sometimes we have problems. Why we have problems with a project that, you know, the sentiment is there, the resentment is there. And what will happen with me when that happens? I mean, I will lose my friends. I don't think so, right? What if I change jobs, right? If I change jobs, they will forget me. Of course they will. I mean, it's normal that they do. Once I change jobs, they will forget me, and that's okay. I think it's very common, and I don't want that, right? I just don't want that, man. I mean, I feel lonely all the time. And I don't know how to thrive in loneliness. Whenever I really watch the videos from Academy of Ideas, the YouTuber men from Canadian, the two YouTuber brothers from Canada, I mean, it helped me for a week, but then I don't know, man. So yeah, I mean, I don't know, maybe the combination of philosophy, religion, and my will to change my situation will be enough. I hope so. I hope so. Alright, let's see what we have here. Okay, so I remember that I wrote down a couple of questions that I wanted to ask ChatGPT to. Didn't I have like another note? Well, my oh, that is my notebook. It's crazy, right? Because I mean, I want a partner, but once I really think about it, I really don't want a partner. I just want a friend, I guess. a true a friend, a truly friend, right? Um, I don't know. I mean, I don't care if it's a man or a woman. I mean, if it's a woman, most probably will become my partner, and yeah, I know that deeply in my heart. I really don't want a partner right now. But of course, if I find the perfect woman, of course I will date her. But as I said, I just want a friend. That's it. I just want a friend that I can count with. I don't know if I will find that in church. I don't. I really find it really hard. But I mean, it doesn't have to be like a physical friend, like a human friend. Could be God. I don't know. I don't. As I said, I am not much of a believer. I am actually kind of the opposite. But I don't know. I want to believe that something is there, so I can put some rocks out of my shoulders. Yeah. Those were my thoughts. I'll continue with this now. Okay, let's see. So one of my questions that I wanted to make yesterday, I will recap from what I learned yesterday. That there is a file descriptor table, and that file descriptor table connects with an open file table, and that open file table have its individual inodes. I mean, for each file, you could be opening the same file, right, twice, but but those two entries that will be on the open file table will point to the same inode. Oh, I'm very proud because I can explain my ideas of English very well. I mean, not that well, but better than I anticipated. Alright, what did I write here? Does every entry will have standard in, standard out, standard error? Yeah, I really wanted to know that. So I will ask my friend here, ChatGPT. Does every file descriptor table, does every entry in the file descriptor table have standard in, standard out, standard error fields? Have I'm so alone. How pathetic, man. I mean, I commit a lot of errors to be alone right now. So I can be alone right now, and now I'm complaining because I am actually alone. Whatever. Pseudo terminal slave. Okay. I didn't know that PTS stands for pseudo terminal slave. That's crazy. point out the same thing. Yeah. I didn't quite actually. I mean, but that was what I was actually thought about yesterday on the video on YouTube. Okay. Oh, okay. Mm-hmm. Right, I think that I kind of got it. Yeah. Um, Alright, this question is answered. Does every entry have a standard input, standard output, standard error? No, basically, I mean, I was thinking that the FD table, file descriptor table is actually a table, you know, in a database. But from what I understood there, it is not like that. Basically, FD tables is an array basically of integers that, but every process have at least 3 slots of I mean, it doesn't matter what progress it is. At least it's a very specific one. Everyone have like standard input, standard output, standard error, and each of them have its own table of file descriptors. Okay, I think that I got this. Does every entry? I mean, that question have to be like. Re have to be rewrite. That question have to be rewrite. No, doesn't sound right. ChatGPT, does that question have to be rewrite? Is that good English? That question has to be. That question has to be rewritten. Why? What is a passive constructor? Mm-hmm. Mm. Okay. So yeah, that question has to be rewritten, because I said, does every entry on does every entry of the file table have standard names? Well, I thought that every table were an actual table on the database that have columns and stuff, but no. Every tables are basically an array. Uh, I will write that. Yeah, sorry, I got distracted. Right. So here it says Pi creates two file descriptors. Why? So yeah, the next thing to understand is what is actually an open file table. So now, what is an open file table? Mm-hmm. System-wide, okay. Mm. Okay. What? Mm-hmm. I don't understand this, bro. definitely need to do meditation, man. I really can't concentrate. I don't know what's this. Okay. I mean, it duplicates, I guess, FD, the FD number into, I don't know. Where is that FD table, man? Mm. What if a process reads file from Mhm. opened an entry by says it doesn't necessarily need an entry in the OpenFT table. Uh-huh. Uh-huh. Yep. Okay. Mhm. Uh-huh. Okay. Alright, I think that I know now. I know. So open file tables are basically like a process that you open. I mean, the process that have the data of that stuff. That means the offset, the inode, the ref count, the number of file descriptors that are associated that makes reference to the to this open file. Yeah. I write that down. I note. At the idle have the supply create two file description. Why? What? Okay. Okay, two entries. Okay, I think that I am getting it. These are entries. These three are totally separated processes. Uh-huh. Uh-huh. Yeah. I don't understand this. Parent and child each other. Okay. Okay. So let me explain what I understand. So let me say what I understand. Basically, a pipe is creates two entries in the open file table. Kernel wide. No. Those two entries have their own file descriptor tables that are independent from each other. Descriptor. What happens when I write command Oh, yeah, of course. Okay. I don't understand what I'm reading, bro. I don't understand anything, bro. For me, for now, this work like magic. So that, uh-huh. Bro, this is too advanced, bro, for me. Okay, okay, I understand that. A pipe creates two kernel level endpoints, one for writing, one for reading. The shell uses the two to connect the standard out of one process to the right, I mean the standard output of one process to the right end of the pipe. I mean the standard in. And the standard in of another process to the read end. The standard in of the pipe. And the standard in of the, let's say, grep to the read end of the pipe, bro. This ChatGPT doesn't know how to explain to me. The pipe buffer relays data between the two. Yeah. Show me the diagram, bro. How much time is it? 1 hour. Huh. What's going on in the shell? The shell before this step behind the scenes. Bro, show me a graph, please. Shell by FD process commander returns the high work. Standard output, standard in to grep. Yeah, I sort of understand it. Alright, let's move. Hey, is that me? So yeah, those were my questions yesterday. I said I will watch this video, so I will do that right now. I should understand everything.
What's going on, y'all? This is Stevie with another episode of Project Twine, and today we're going over a common phrase that you'll hear when working with Unixy type.
Can you hear that, right?
Systems.
Yeah, you can.
And that is, everything is a file. So we're gonna go a little bit into what this means and give you a couple examples of it in play, as well as trying to understand the rationale behind the phrase. So what's the rationale behind using everything as a file? Well, if you think about it, everything on your computer is really just a stream of bytes, or a bunch of characters just put together that represent a bunch of different things. So if we have everything represented as a file, that means we have one protocol, just one protocol. And so if we understand how this file represents a bunch of different things, really just a file. Well, if you think about it, everything on your computer is really just a stream of bytes, or a bunch of characters just put together that represent a bunch of different things. So if we have everything represented as a file, that means we have one protocol, just one protocol. And so if we understand how this one thing works, we understand how a lot of different things work. This allows us for better interoperability. So we can use a bunch of different tools together with the file format, and we can reuse tools and make them understand how this one thing works. We understand how a lot of different things work. So this allows us for better interoperability. So we can use a bunch of different tools together with the file format, and we can reuse tools and make them communicate with each other. And so we're really aligning ourselves for a much better form of modularity. The most important thing, in my opinion, and you'll see this in just a couple of seconds, is that by using this simple text file format, we have a really good sense of transparency when we're working on a Linux system or a Unix system. You'll start to see that pretty much everything, really everything, is represented as a file. But all of these things that I just mentioned, so modularity, like interoperability, like transparency, these are all part of the bigger picture. So the original developers and the original kind of founders of the Unix operating system came up with a set of approaches, a kind of mindset that you bring when you're building software technology. And throughout your engineering career, you'll start to see how deep of an impact this sort of mindset has had, and how it's leaked into pretty much like everything that we do as engineers. we can just think of the practice of having the text file represent a lot of different things as being one of the core principles derived from this Unix philosophy. I found a really good quote from the book The Pragmatic Programmer, and the author mentions the idea of combining small, sharp tools and the use of one common underlying format, and that is the line-oriented plain text file to accomplish much larger and complex tasks. And we'll see this in just a couple seconds. Alright, so I'm logged in onto a plain CentOS server here, and I'm just going to run through a couple quick examples that demonstrate that everything in Unix is really just a file. So let's start off with the very basics. So let's go ahead and just create a file called basic text file.txt. And I'm just going to write hello there, and then I'm just going to quit out of it. And let's go ahead and also make a directory, and then I'm just going to list out what we just made in a detailed format. So in the first column, you can see that basic text file has a dash, right? And the one below that has a D. So what's going on here? Well, basic text file, the dash represents that basic text file is just a regular file. And the D represents that the directory that we just made is also a file, but a special type of file called a directory. So what I'm trying to show here is that the things that we kind of take for granted, like a directory, is just a file. It just takes a different type of perspective to see that a directory is also just a file, but it functions slightly different than a regular text file does. Alright, what I'm trying to show here is that the directory that we just made is also a file, a special type of file called a directory. So what I'm trying to show here is that the things that we kind of take for granted, like a directory, is just a file. It just takes a different type of perspective to see that a directory is also just a file, but it functions slightly different than a regular text file does. Alright, so you'll start to see that everything in Unix is just a file now, right? Well, let's go ahead and explore some other things. Well, this ls thing that I've been using, is that a file? Well, if I go into /bin and I use ls, and I look for ls, interestingly enough, it's right there, and I just do ls-l, and just like, let's only look for the things that are start with or end with that ls, and you'll see that this is also just a regular type of file. So that must mean that executables, or the things that we use to run our system, are just files as well. That's really interesting. So this goes even much, much deeper. And so what if I try something like going into this directory that I made?
Wait a second. So this file, okay, I feel that it was like a pointer, right? But I don't know what exactly is inside that pointer. I guess that is the the reference to where these I don't know, honestly. I know it's a file, but it's a file that holds like this. I mean, that is. Well, I have the sense that I have been living in a simulation or something, because I knew that this was like a sort of directory. That's why it's named directory. But this use fds. I mean, this file they rank you have a list of reference. Use fds.txt is just a reference. It's just one more reference, right? And when I go into this txt file, I just go to where in memory it is, but for the computer, rank you use fds project. I mean, they are sort of like in the same. I mean, they are like all the same, right? They are like all the same. Just for me to visually represent where something is where we where is something. I mean, that's why you divide it this way in this way. But the system doesn't see it like that. Yeah, like in the same way as me. I mean, he just see pointers. It just sees pointers and you know these all are pointers, right? I mean, when I do like big use FDs, I'm just you know uh, going to the space in memory, disk in memory of that file. Sorry about my English, but I really can't think now because of how close my nose is. I'm sorry. I will put this shit on my nose. Wait a second. Fuck. Yeah. So yeah, now I see that I mean this regular file doesn't have an executable. I have just realized that. And why do they? And why would they, right? But what if I go to an actual executable, like from my C files, right? Let's see. Do I have anything here, right? No. I realize that directories are files that can be executed, and the execution, I think, that returns something like the position, some kind of reference, some kind of pointer. Fuck. Yeah, this is an executable. Yep. Yep.
And then let's run vim in the background. So this ampersand, you don't really have to care about it for now. And then let's run vim in the background. So this ampersand, you don't really have to care about it for now, but the ampersand means let's run it in the background. So I'm going to run it in the background.
I didn't know that.
It gives us a number, 7,127. What does that mean? Number 7,127. What does that mean? Basically, Unix is assigning it a number. So if I go into /proc, right, and I list things inside there, and I look for that 7,100, right, and I list things inside there, and I look for that 7,127 number, it's there for some reason, and it just came out because I ran that process. So what does that mean? Well, that means that the processes are even represented as files. In this case, these files are directories. So if I look for that 7,127 thing, there it is, a D. So it's a directory. Interesting. So what happens if I go into that directory and I ls the things inside? Well, you'll start to see that all the attributes of that file are actually listed right here. What about things like where we ran that file, as a matter of fact? If you might remember, we ran it from that directory that we made at the beginning, which was like the tilde and then directory, right? So if I want to find out where a process is actually running from, all I need to do is look within my own file system. Crazy, right? So if I just do ls-l on cwd, which stands for current working directory, I see that it's right there. So this is a system. Crazy, right? So if I just do ls-l on cwd, which stands for current working directory, I see that it's right there. So this is a symbolic link. It's a different type of file, but nevertheless, it's a file, and it's telling us that we ran vim from that directory called /root/directory, which would be accurate. It's right there. So it's D, which stands for current working directory. I see that I have a number. Attributes of that file are actually listed right here. What about things like where we ran that file, as a matter of fact? If you might remember, we ran it from that directory that we made at the beginning, which was like the tilde and then directory, right? So if I want to find out where a process is actually running from, all I need to do is look within my own file system. Crazy, right? So if I just do ls-l on cwd, which stands for current working directory, I see that it's right there. So this is a symbolic link. It's a different type of file, but nevertheless, it's a file, and it's telling us that we...
Okay. I don't know why it keeps getting me back here. Yep. Oh fuck! I forgot to to do my camera. Where was I?
We ran vim from that directory called /root/directory, which would be accurate. And that if we do ls-l on exe, as a matter of fact, we start to see that this even tells us where vim is located, which is really crazy. And this is also symbolic link, but it's basically here to demonstrate that everything that has to do with our system is shown in our system and just as files, and we just have to look within our file system to really recognize what's going on inside our computer. So I just showed you how processes are really inherently transparent, because when you create a process, there's a corresponding directory or a type of file that's made in /proc that you can just look into and discover more about. So this is kind of that Unix way, that Unix philosophy of being very transparent about your software, because we can just go into our file system to learn more about what's going on within our computer. So I'm going to take this one step further and show you that concept of interop.
Okay. Oh, brave. Okay. Crazy.
Interoperability, which is the idea of being able to use different tools together. And this is only possible because everything is just a file. So let's go into /dev here, and it's going to list everything out. So on the right hand side, I just want to point this out that XVDA1 and XVDA are actually representative of my hard drive. Interesting. So if I just ls-l XVDA, you see that this is also just a type of file, but it's a special type of file. It's called a block device file.
Oh yeah.
Which is the idea of being able to use different tools together. And this is only possible because everything is just a file. So let's go into /dev here, and it's going to list everything out. So on the right hand side, I just want to point this out that XVDA1 and XVDA are actually representative of my hard drive. Interesting. So if I just ls-l XVDA, you see that this is also just a type of file, but it's a special type of file. It's called a block device file. If you are paying close attention, you might have also noticed that there's files called standard error, standard in, standard out. And if you've programmed before, you would know that these are really important things in terms of being able to work with input and output. And as a matter of fact, if I just use one tool that you might have known, echo, which just basically echoes things back out for us. If I echo that in to standard in, we actually get that right back out, which would not be the case if I put it out into something else, right? So basically what I'm showing here is that I'm using these...
Why are you using double of those stuff? We can just use... Yeah, we're using two. I don't get it. How did I use standard out? I mean, there is no way. You have to split something here.
These two different types of files that are being kind of created spontaneously and being able to use them to get right back out, which would not be the case if I put it out into something else, right? So basically what I'm showing here is that I'm using these two different things, these two different types of files that are being kind of created spontaneously and being able to use them together. Now, this is just scratching the surface of the type of things that you can do with the text files because everything is represented as a file. As a matter of fact, if I wanted to, for example, create a file to print, right? So if I go print file.txt and go, hello, I want to print this, right? Interestingly enough, if I wanted to print this, all I really need to do is to, I could just cat print file.txt and then pipe that into lp-d and then put it in my printer name here. So this is crazy. This is a simple command that I'm just like putting together, and because everything is represented as a file, so even my printer, I can just, spontaneously print things off my command line. And so this kind of sums up, and I hope this is showing you as a demonstration of how everything is.
What is what the fuck is LP, bro? Print files. What? Sorry, I know that you can't see what the terminal is looking at, but I'm doing actually this. Ah, fuck.
Everything is represented as a file.
So if I go like here, I don't know what I'm doing. I don't know what he wanted to do there.
I wanted to print this. All I really need to do is to, you know, I could just cat print file.txt and then pipe that into lp-d and then put it in my printer name here. So this is crazy. This is a simple command that I'm just like putting together, and because everything is represented as a file, so even my printer, I can just, you know, spontaneously print things off my command line. And so this kind of sums up, and I hope this is showing you as a demonstration of how everything is really just a file. And because everything is just a file, in that Unixy sort of philosophy, in that Unixy sort of way,
What?
we're suddenly empowered to do all these things by combining these little tools, and because they're so modular, and also because they're files, it's so transparent. We can learn so much about our system. And in that Unixy sort of way, we're suddenly empowered to do all these things by combining these little tools, and because they're so modular, and also because they're files, it's so transparent. We can learn so much about our systems just by exploring through our computer. So I highly suggest you do the same, and you just like go through your computer and you just look on, you know, on the different types of files that you have, and you'll start to see that really that phrase is true. Everything is a file. Well, to be more specific, everything is represented as a file. Now, I hope that was helpful. My throat is dead because this is my 95th recording. So I hope that was helpful. And until next time, good vibrations.
Nice.
Hey, what's going on?
Hey, did I see a meme here?
Back in 1969, a couple of computer scientists here at Bell Labs started to develop some programs they needed for their own use. What Ken Thompson and Dennis Ritchie started developing then has evolved into the Unix operating system, which by now is widely used not only in Bell
Dennis
systems,
Ritchie.
but in other places around the world. In the next few minutes, we're going to tell you about a few of the problems that Unix is useful for, and we're going to talk some about both operating systems in general and the Unix operating system in particular to show you how Unix helps people solve problems.
If you look particularly at Bell Laboratories, but at high technology industry in general, there's a tremendous need for better techniques and tools to make our work more productive. We just simply cannot write all the software that needs to be written. In fact, a good analogy is that a number of years ago, when telephone calls were switched not by computers but by human beings, operators, people predicted that sooner or later the entire population of the United States would have to be telephone operators to switch all of the calls that needed to be switched. We have the same problem in programming productivity today. Now, keeping large amounts of software working and keeping it working in the face of change simply takes a lot of people. In the Bell system, we have many millions of lines of software. We have thousands of mini computers, we have hundreds of very large computers, and there is a lot of software that needs to be kept working. There's all different sorts of software. There is the switching software that switches your telephone calls. There is administrative software that administers the entire process. And there is, for instance, the billing software. I mean, how many systems do you know give you a bill for something that costs as little as 10 or 20 cents? There's a lot of software. So we need lots of techniques and tools to make this more productive.
The programs which tell a computer how to switch a telephone call, or compute a payroll, or play an electronic game are called application software. There's another type of software, the programs which control the resources of the computer itself, the memory of the computer, the processing elements, and the terminals connected to the computer. This latter type of software is called an operating system. Another way of saying what an operating system is that it's a collection of programs which make the intricate hardware of the computer seem more simple and comprehensible from the point of view of an applications programmer, so that the applications programmers can create software more easily.
We are trying to make computing as simple as possible. In the late 1960s, Dennis Ritchie and I realized that the then current operating systems were much too complex. We attempted to reverse this trend by building a small, simple operating system on a mini computer.
Well, what we wanted to preserve was not just a good programming environment in which to do programming, but a system around which a community could form.
Hey, it is
Fellowship. We knew from experience that the essence of communal computing, as supplied by remote access time-sharing systems, is not just to type programs into a terminal instead of a key punch, but to encourage close communication.
Unix started out as a two-man effort, and by now it's used all over Bell Labs. We have close to 20,000 computer terminals in this company, roughly one per employee, and most of them are used for communicating with Unix systems. One of the main reasons that Unix is popular around here is because it provides graceful facilities for decomposing complex computing tasks into simple subtasks.
The Unix operating system is basically made up of three parts. The kernel, or operating system proper, is the part that manages the control of the machine and supervises scheduling of the various user programs. The shell, which is the name we give to the command interpreter, looks after the communication between the user and the system itself. The third part, which is actually the largest, is the various utility programs, which perform specific tasks like editing a file, or sorting a bunch of numbers, or making a plot. In other words, all the other programs that are not provided directly as part of the operating system kernel.
One of the things about Unix is the ability that we have to create complicated programs by building them out of simpler programs. Rather than writing programs from scratch, we can often construct them just by gluing together existing programs, almost like building blocks. Let me show you an example of how that would work by writing a program, without actually writing a program, to find spelling mistakes. One of the things that Unix has been used for a long time is document preparation, helping create letters and papers and books and so on. So let me write this spelling mistake program. I'm not going to do it for a whole document because we don't have one, but let me print a single sentence. The sentence comes from a paper that John Massey and I wrote. And if you look at it carefully, you can see that there are actually a couple of spelling mistakes in it. So, suppose that we wanted to use a computer to find those spelling mistakes instead of doing it by hand. Basically, what we want to do is to take each of the words in that sentence and compare them against the dictionary. To compare it against the dictionary, which is sort of one word per line, it's certainly going to be easiest to convert this into one word per line. So let me run a program called MakeWords, a program that already exists. We'll take its input from sentence, and we'll dump the output into something that I will simply call words. Now, words is a file, just like sentence. Let's look at that. And there it is, all of the words, one word per line. Now, if I want to compare those against a dictionary, I've made some progress, but it's clearly not done yet. Because, for example, my dictionary doesn't have the word bell or the word laboratories with a capital letter at the beginning. It only has them in lowercase. And so if I do a blind search, I won't get the right answer. So the next thing I want to do is to convert words into lowercase. And so let me just run a program called lowercase on words and dump the output, in this case, into something that I'll call LC words, inventing file names as I go here. And let's look at that one and see how we did. And sure enough, bell and laboratories are in lowercase. So we're getting warmer. We're almost at the point where we could compare these words one at a time against the dictionary. The dictionary is in alphabetical order, and it will be a lot more efficient if we only go one pass through my list of words and one pass through the dictionary rather than sort of poking randomly at the dictionary. So let me sort my list of words. So I will say sort LC words, and I'll put that one into sorted words. And let's see how that worked. And sure enough, they're sorted into alphabetical order. Over sorting, it shows us something else. Notice that the word systems appears twice there, and that seems kind of silly. And now in a single sentence, it doesn't really matter, but in a big document, it'd be very nice to get rid of all the duplicates. So let me run another program, which exists on Unix, called unique, and I will say unique from the sorted words into the unique words. And let's see what we got here. Sure enough, the word systems, the duplicated word, has gone away. And now we're almost at the point. What we want to do finally is compare the list of words that I have here with the dictionary and print the words that are in my list that are not in the dictionary. And we'll do that with a program called mismatch, where I simply say mismatch, and then we'll go from the unique words and the dictionary. Those are my two sources of input, and mismatch will simply print all of the words which are in unique words that are not in the dictionary. And?
I mean, yeah, I will watch this probably when I want to sleep or something. I mean, not because it's not entertaining, but you know, to be in my bed and watching it. Right. I don't know if I have much to do now. As I say to you, I want to go to the church tomorrow. And I want to take a shower since I haven't done that in a couple of days. Maybe wash my face then. Yeah, that would be great. So yeah, I guess that's everything from me now. I have learned a lot, I guess. I mean, I could keep it all, but honestly, I already got sick of it. So I don't know. I think I already I mean, everything we have done just to understand this this sentence. It's crazy. Yeah, that's how I usually study. And this is a really hard way to study because you go sideways a lot because of things that you don't understand. Because if I keep reading this, I will be still thinking about, geez, everything is in Unix is a file. But why? So, so yeah, that will keep concentration out of me, and I don't know, man. I don't know. I don't know. So yeah, as I said, this is a hard way to study. At least it is for me, but it is just how I am, right? I mean, I have to know why. I mean, there are limits, of course, like for example, that do two at the fork stuff that I didn't quite understand 100%. But, sorry. Uh, but, you know, these more like superficial things, why not? I mean, why not give it a chance to understand it? The thing is that in the long term, it makes me feel like, come on, man, I am not making any progress. Maybe I'm not that smart, etc. And I stop studying. Yeah, but I guess, but I hope that with this, streaming, I can, be more persistent. Since I try to make it as I don't know, as entertaining as I can, giving my background, since I don't know many of this stuff, right? Oh, what's uh, I don't know many of this stuff. I am not that young anymore, so it's hard for me to not sabotage myself, sabotage myself, sabotage myself. Yeah. So yeah, it's been 2 hours. Well, I always speak at the beginning, um, so it will be like 1 hour and something, and 50 maybe minutes. Uh, so yeah, let's leave it here. I will continue tomorrow. I will probably gonna read for a while now. I probably will change books since I am not liking that much that I am reading. Maybe I will try another one. Maybe we'll try some horror book. Yeah, that would be that would be great. Uh, Because I read Elantris from Brothers and to be honest, I am not liking it that much. uh, I am in the 8% of the book, so it is not like I've been reading. I've been reading a lot, but I haven't made a lot of progress since some words, I have to. I mean, I have to stop every few words to search the meaning of one of them. Since of course I don't know all the words that are written there. Sorry. I want to know if I communicate my idea well. Chat GPT. Since I don't know all the words that are written there. Is that good English? I don't know all the words that are written there. Why is correct? fair. And yeah, what else? What is a socket? What the fuck is a socket, bro? What the hell is a socket? I don't fucking know. Yeah, I fucking make stuff, and that's why I haven't made that much of a progress. Not only that, but this book doesn't interest me a lot. Doesn't make me interested. Doesn't interest me a lot. The book doesn't. Oh fuck! Another one. The book doesn't interest me that much. The book doesn't interest me that much. Yeah, engaging would be better to say. The book that doesn't engage is not that it's not that engaging for me. Engaging. Yeah, well, give it a chance now. So yeah, that's it. See ya. Well, it's already 12 and 2 a.m. So see ya later.